last session of Google Cloud Camp, and today we'll be talking about Google Kubernetes engines and other serverless options. And I'm here, Google Cloud Camp facilitator Rupak Vishwas from third year BTech. So the problem is, let's say you have written some application, let's say in a web application, and you need to give the application to your friend or somebody, or a tester, I guess. So how will you give your code to them? Please write in chat box. I I want to see some answers. Uh, you should you should register the RSVP in the website, I guess, for proper attendance. Okay, so can somebody answer? Like, you guys, you have some code written, and you want to give the code to your friend or a tester. Is my question clear? Okay, that was some advanced answers. Some other answers. Okay. Uh, let's say I have some code written in some language or something, and let's say this is a code for okay APK files. Okay, this is for app, I guess. Fine. Let's say I have a web application, a full stack web application, and if I have to give the code to some of my friend, then I might share him my source repository link, or I might be I might be zip the whole code and send him the source zip file. Then I think I will be sending some instruction also for running the code base. Like for a node application, there might be some node dependency. So I'll be telling him that these are node dependencies, and you should install those dependencies first. Okay. So and there might be some other dependencies also. So I will tell him to install those dependencies also. And next, there should be some specific commands to run the application. And after you send those code base and applications, uh, is am I audible? I guess my network connection just got broken. Hello. Okay. Thank you. So let's say I have given some of my friend my uh, code files and send him the instruction to run those codes. So what he will do, like he will run those codes, and most of the time you will face an issue, like because and you will say like those codes run in my machine. Okay, so the problem here is like other than code dependencies, there are is my screen visible, I guess. Yes, yes, right. So sorry for the inconvenience. So I was talking about like many time it happens like we give our code to someone and we give proper instruction how to run this code, but they face some issues and those code run in our device properly. So there was not any proper method to uh, containerize those things. So here it come the method container. So what container is like we give our codes and all the instruction how to run this code and it creates an image. So this is like similar virtual machine, but there are some lots of difference between a virtual machine and container. So what is Docker or container anyway? If we understand what a Docker container is, let's understand what it's replacing. The virtual machine, of course. So what is a virtual machine? So let's say a server is a piece of hardware, right? Like a type of computer, and a OS is dedicated for that hardware. Let's say a Linux server is installed on those piece of hardware, and now I want to install Windows also. So same thing applicable for a personal computer as well, not for a server only. So before virtual machine existed, how we do that? Like we uh, we need some two piece of hardware or dual boot, I guess. Yes, we need dual boots or two hardware we need for running two OS. Then, but that's not a good idea because we can't run those two OS simultaneously. In case of dual boot or uh, for for the other thing, we need two piece of hardware. So that is not a good solution. Then, uh, so there, what virtualization came into the picture. For uh, what happens here, like there is something called hypervisor, and we install hypervisor instead of our host OS in those hardware. And hypervisor is kind of like an OS, but the difference is like it has one goal: divide your hardware resources into multiple OS. One most popular hypervisor is VMware. I guess most of you use it to learn to run Linux on Windows. But that is not how Docker works. So the virtual machine virtualize the hardware, but in Docker or container, it virtualize the OS. So for running Docker, we install one host OS, then virtual machine virtualize the hardware, but okay, but we install one host OS. Let's say this is Ubuntu. Then our buddy Docker comes in, and like any other software, we install Docker, which runs as a service, like as a daemon in our host machine. And we, for running any application, we just pull those images from our registry. So there is one standard registry for Docker containers, like hub.docker.com. You can visit that. Using Docker images as easy as running printing hello world. There is a Docker hub I told about. So there are millions of Docker images in that registry. You just need to download those images with a single command: docker pull, then the image name, and with the next command docker run that, and with some flags you run the image. That's it. To work of only two commands. So this is obviously very easy thing to run a single Dockerized container. Creating those images is a bit complicated. You can learn those things. Uh, the resources are available in internet. You can learn how to create Docker images. Then there is no need to check for OS requirements or language requirements. Uh, then next slide, please. Silpan, next slide. So in container, those containers are lightweight, portable, then they have a better productivity and also secure. And you don't need to configure those OS requirements every time. You just specify the base OS, then you put your code onto this, then you write those instruction on the Docker image, uh, Docker instruction page. So no need to set up all the things manually. You are ready to go. Cool, right? So everything going fine. So why we need the Kubernetes here? So also I forgot to mention, like in Docker you can run any language. Your application is running cool in your machine, then you might need to build those application on Docker, and you can give the Docker image to anyone. That's it. They don't need to install any kind of dependency. They are ready to go with your Docker image. They will just pull your image and just run. That's it. Next slide, please. So why Docker container? We already covered, I guess. So this is less overhead. Then it manages less. It requires less resources because it is not actually virtualizing the hardware. It's virtualizing the OS. So what it does, like one thing I should mention, like in Docker is available for Windows also and Linux also. But in Linux you can only run Linux images, and on Windows you can run only Windows images. So the thing is here, like in case of virtual virtualization or virtual boxes, so just share the hardware. Okay. So let's say you have 8 core computer, and you specify 4 core for Windows and 4 core for Linux. Then you have 512 GB of hard disk or the SSD. Then you have the storage system, and you divide the hardware to both the worlds. But in case of for Docker, our host OS is running cool, and the other virtual containers, they use the same kernel as the our host kernel. So this is where the productivity becomes light. Also about its efficiency, this is very easy to run. For creating Docker image, it takes some time, but for running those Docker images, this is absolutely very much time conserving. They need to download those images and just run. Next slide, please. So Docker was released by .NET Cloud, currently named as Docker, and it is made easy to fast and create running containers. So these the flowchart are like the uh, workflow of Docker. You need some blueprint, the instruction set, how to run those project. You create a Docker file and write all those instructions on this Docker file. Then create the image, and you can upload those image in Docker Hub registry. Where I was for you storing those images. You can visit hub.docker.com. There are lots of public Docker images there. Then you can pull those images, and on from a single image you can run multiple instances. So that's how you use Docker. Next slide, please. And also everything at Google runs in container, from Gmail, web services, maps, YouTube's, everything. Even the Google's cloud platform, uh, Everything's run in containers, and they launch over 4 billion containers per week. These are some of the fact. Next slide, please. Okay, so we saw like how easy deploying a single Docker container is, but the problem is like totally different. So in case of production, we need multiple Docker instances, multiple instances running together to serve our purpose. But managing all those Docker images together is quite a challenging thing. So let's say I have a business or I sell something, and I have a full uh, full stack website for that, website and app, I guess, for that. And I have database server separate. There are API services running on multiple container. Let's say 5 6 container is serving my APIs. Then my web page is served by 2 or 3 containers, or some other internal analysis computation is done by some other containers. Okay, so that's uh, I think I am making this thing complicated. So for now, let's say I am running this whole application in single container. Cool. So my business is running smoothly. Okay, not just smoothly. I have a hike in our customer service that the amount of load can't be handled by a single container. So we know what to do, right? So let's add some more containers. Let's say we added more 2 3 containers and add some load balancer also, because load balancer is necessary to balance the load. So in a month, my customers increased, and as well as the traffic increased. So by a factor of 10, I guess. So now we need more more virtual machines. Let's say we need now 100 virtual machines, right? So even though virtual machine running these virtual machines, containers are running very easy. You just need 2 commands. But running 100 containers is like pain. This is painful, right? I had to set up configure also. I had to set up multiple load balancer to correctly uh, balancing the loads. So 100 Docker images also pain, even though this is very simple. So let's say I have a good friend. So we set up 100 Docker containers running. Cool. Everything going fine. But the next day, our developer just finalized the new design for, for our website. And now we are ready to publish our new website. So what we have to do, like we have to again stop those 100 containers and again start those 100 containers. Or let's say like uh, from those 100 containers, one container got hacked. A serious vulnerability got discovered in any of our services, and they got some reversal access. Okay, they can't damage the whole system. My system is running. Only one container got hacked. So we also figure out what the problem was, and we need to fix those vulnerability from those 100 of containers. So again, this is a painful thing. We have to change so many instances. So this way only one of the container for a project. Now imagine the same system with the multiple container system. I think this example was for a single container. My whole application was running in a single container. But now let's imagine my service is running in multiple containers. Like the example I gave earlier, with like my some of my containers are serving my APIs, some of my services are served by some other containers. Content is served by some other containers. So that is a horrible case. I know a good friend who knows how to solve this issue and who will be working on this for me. Yes, I'm talking about Kubernetes. Uh, Please change the slide. This is Kubernetes, and uh, This is, this is a open source project and support multiple container runtimes. It was inspired and informed by Google's experience in internal systems. So before publishing this project, Google already used this thing internally, and now this is open source. We can use this Kubernetes not only in Google Cloud but locally also. But this is another problem. Then also other cloud providers like AWS and Linode, they also provide Kubernetes services. So and you can see those source code also because this is open source project. Next slide, please. So in simple term, think of Kubernetes as your OS for your compute page. So uh, we have one master node or master virtual machine, and I will be talking to this master node only. So I'll not be directly connecting all those running instances. So whatever I need, I will ask the master node. He will be doing all the jobs for me. So it provides similar to an host OS, and it does all the scheduling workloads and finding the right host for your right workload. It also monitors the health for your every instances. If some of those nodes are going to uh, working, if some of the nodes don't work properly, then you're gonna have some, let's say, email notification or whatever you set up. Scaling it up and scaling up and down is also its job. You can specify if the network load is up by this, and you can add some this amount of instances, and the network is not up to this much, then you can reduce some of the instances. Also, if you like you want to move those clusters from one place to another, this is a better option. Next slide, please. So simply container management, uh, like this is a declarative management. So here, so here to run a Docker instance, like sorry, Kubernetes server. So there is two options. Please next slide. I will come back to this slide later. Yes. So this is Kubernetes architecture, and there is two plane, one control plane and the running instances plane. So the control plane, we can call it master node also. So there is multiple services running on in our background to control those containers, and we will be talking to this master node with the uh, Kubernetes public API. So there are other ways like kubectl command also for talking to this Kubernetes service, but the underway like command also use this API. So next slide, please. So you can create an YML file, manifest file, and here you describe what you need, what you need in this cluster, like for how many instances you need, or what will be the load balancer, or anything you want. You will be writing everything in this YML manifest. And once you are done with this YML file, then you uh, submit this UML file through the API or the kubectl command. So this is the structure of the command. And once you submitted this YML file, then done. Now you don't need to worry about your instances. Now Kubernetes will be working for you. That's it. Next slide, please. So these are the services Kubernetes run inside. So the smallest of them is pod, and you can configure some cron jobs. Cron jobs are like automatically running commands. Like you can schedule something like for every day you can run some commands at a specific time. So this is for what cron jobs is. Then you can configure some volumes, how much volume you should assign to which instance. Then there is service accounts and service quota, persistence volume claim and persistence volumes. These are some of the some of the services QCTLs have, and you can go into this one by one. These are the services we also use in our development system, but in case of we manage what we want to add those things in our nodes or containers, we can specify those things in our YML file. So this is what we're all about. But this part thing is necessary. Like we have to mention how many nodes we want to run and what image we gonna run on those containers. Uh, can you come back to the last slide in this? So here we can see this is yes, this slide. So the declarative management is the YML files. This is called the declarative management, where we declare what we need to use, how should it work, and how it should react on some other events. So all these things we declare on this YML page, and this is a portable platform. So every time we get some changes in our images, then we don't need to configure them manually one by one. We just tell this master node that we need to change the images, and he gonna change all the images for us. Not all. We can specify the number also. Like in those number of instances, we can change the images for that. This Kubernetes mainly gives us an abstraction on those management systems. So this is the main job of Kubernetes, to give an abstraction of the managing all those containers running on. Next slide, please. Next slide. Okay, so these things we already covered. So Kubernetes handles scheduling. We can schedule some of the works, and we can decide which pods or which nodes should run on which time. Then it checks our containers health. If some of containers get hacked or they perform low, then it will be notify you. Then we can scale those containers or number of containers. Then we can set naming and discovery, how you can find those containers. Let's say you have configured some 5 or 6 containers and you want to manage those containers manually. So you can give them some name, or you can assign some random names so that you can access those containers one by one if you want. Then about load balancing, this is one of the main thing, distributing traffic across a set of containers. So also Kubernetes handles storage volumes, logging and monitoring. The logging and monitoring is another service. This is it also It logs and monitors all those information on any service running on Google Cloud. Then there is debugging and introspection and identity authorization. These are something Kubernetes also handles. Next slide, please. Okay, but getting started can be challenging, right? So I suggest that if you want to work with Kubernetes, first of thing, if you have an existing project, then you can go start learning Docker, how to write a Docker file, how to build image from those of your project. So there are many resources available in the internet, and once the Docker file is ready, then you can go for learning Kubernetes. In our Google Cloud Learning Path, there are resources to learn Kubernetes and labs also. But if you don't have a project, so first focus on building this project, then you can build the Docker image, everything. Next slide, please. Okay, so this is so okay. So Docker image, building Docker image is another challenge. You gonna spend a lot of time building the Docker image for your application. So uh, there is some tool in Google Cloud to build those images for you. And also for the first time, if you are running Kubernetes engine for running your Docker images, then you're gonna be like confused. Like lots of configurations are there, and so what Google did, like they made an autopilot system on their experience. So this autopilot choose the best configuration for you, and I think this is the default one. So if you run the Kubernetes with lesser configuration, the autopilot gonna work on the background and choose the default configuration for you. So you don't need to use this autopilot. It is I think this is the default one. Next slide. Yes, this is the Google Cloud autopilot I talked about. Next slide. Okay, so we're done with the Kubernetes services. Let's talk about serverless compute. I guess, we talked about serverless compute on our second session. So let's explore further. Next slide. So I think you are familiar with this pyramid. So in serverless computation, we only think about our application development and performance monitoring. We don't need to set up our hardware architecture or configurations files. So what we need to do, like we have to build the application and just give the application to our serverless services. They're gonna run it for us, and we're gonna have some analytics, performance monitoring, etc. That's it. So, but there is some problem on this serverless application. Like not problem, like there are some restrictions on this, like in cloud function. Next slide, please. Okay, like in cloud function, there are not many of the languages available. There are limited number of languages available, and you have to write your functions in a specific manner so that they can understand. So this is another option, serverless compute app engine. So this is a great application for if you have a single running application or in a containerized app. You have a you have Dockerized your application and you have image for that. Then if you want to run your image first, then you can go with the app engine. You just need to provide your app engine app image, and it's gonna run it for you. It is going to manage its health issues, networking, and other uh, fellow. So it's going to care about the health and networking systems and other architectures. You just need to give the containerized image. That's it. So it is going to also auto scale the application. If only two instances, they need two instances, then they will be like, if they need more instance, they will be adding some more resources on those applications. And so you don't need to configure those manually. So if you have a single application running on a single container, so rather than going for Kubernetes, App Engine is better option. They're gonna give you HTTPS connection also for your API endpoints or those access points. Next slide. And there is cloud functions and cloud run. So App Engine is quite old, like it was built in 2008, and there becomes cloud functions. So for cloud functions, I talked about earlier, like they keep a limited amount of language support, and we need to build our functions in those in a in a manner that they can understand. So there is a format for running those code, writing those code. We need to write our logic on those format, and we're gonna submit our code only. They're gonna run those codes as a fully uh, as a standalone instances. So in the background, cloud functions and cloud run also uses app engines. So yes. So next slide, please. So these are some of the serverless family of Google Cloud. Uh, Google Cloud. Mm, for building and running those applications, we have cloud built for serverless CI/CD integrations. Then we have cloud functions and cloud run for running our applications. Cloud functions for running direct code, and cloud run is for running containers. Orchestrate, we have cloud workflows for managing our workflows. We'll be talking this later, I guess. There is cloud scheduling. This is a cron in the cloud. Like if you use a Linux system, there is cron jobs by default installed in our system. So those cron jobs execute certain commands. We there is a cron config file. We configure some commands on those config file, and cron jobs run those commands in specific time automatically. So this is the cloud version of our cron job, cron scheduler. And there is event arc for asynchronous event delivery, cloud task for task execution. This is similar to cron job, but for task execution. Then for connectivity, we have cloud pub sub, then VPC access and API gateways. And App Engine is like a hybrid system. Next. So if you build some full stack application, from deploying those applications, from building those application to deploying, we follow some workflows. So first of thing, we use some ID or code management system. Like most of us use like VS Code, or for our uh, code tracking system we use Git. So we build our code with their source control. Like we have Git, then we build our project. Then it is going to be in the deploy stage or the scanning stage. So scanning is like container analyzing, like security scanning or something. And we deploy our code in development stage. And there are multiple system. There are multiple runtime. Like we have in first we have dev stage, then there are prod, then stage, then the deployment production stage. So there are multiple stages in which the code goes from one to another, and in every stage there needs some verification. Okay, so and in the last stage, the production is done. There are cloud logging and monitoring for monitoring those services running if any of the service get hacked or something. So, so in every stage, Google have some of application to help us. Like for the first stage, writing our code, there is in VS Code there is some extension cloud code to help us with the cloud coding system. So we can directly code in our containers or virtual machines with this extension. And there is cloud version for writing code indirectly in our browsers. Like our Git, they have some cloud source repository. This is like a Git. There is cloud build, artifact registry. This is similar to our uh, Docker Hub. So they have their Docker Hub artifact registry. Then there is cloud deploy for deploying our code. And for the runtime, they have Kubernetes engines, cloud run, cloud functions, computer engines, Firebase, and these things. And for monitoring, they have the cloud logging and monitoring. So they have uh, one or many applications for those all those development lifecycle. Excellent. So why choose cloud run? We also already covered this thing on Excel. So this is like running a cloud run. You just choose the Docker image and they're gonna uh, run those images in one of the machine. You don't know even you don't know what machine you're gonna run, but they're gonna run it for you, and your application gonna run perfectly. Next slide. So this is what's happened with your container in cloud run. You give your container and they just the cloud run provide you cloud SQL proxy socket, secret message manager for managing your secrets. There are environment variables you should have, and there is workload identity or health security or cloud observability, default front end, and that gives HTTPS connection also. So you just give your container image, and they gives like all the fundamental things. You don't even need to worry about. So this is the best option for your containerized projects. Next slide. So these are some use cases. Uh, I guess so. For public websites and APIs, and public private services, data processing, you can use the cloud services, uh, cloud run, containerize your applications and run those services. Next. So okay. So why should you use cloud functions? So this is if you want to just deploy some simple application or single function application or single API. So this is a best option. And you have there support for mainly used popular used languages. So it should not be any uh, issue. Yes. And you can trigger those cloud functions by any other services also. This is a main thing. Uh, this is mainly used for triggers. You can trigger a cloud function and it's going to change some of your configuration, or it is going to hit the database entry or anything you want. So this is why cloud functions are used. Next slide. Okay, so cloud functions are very easy to use. They have given some format how to write code, and they will only accept those code in those format. You just need to write your logic on those format and submit those codes to the cloud function. They're gonna run those functions, and you're gonna get your API endpoint to share to work with. Next. Next. So this is how you create services. You can launch the cloud and functions servers very quickly. And Google Cloud offers hundreds of thousands of services with lots of third parties. You can use external APIs or SaaS APIs, private APIs, anything. You can choose any kind of configuration, any set of tools to work with your project. And there are multiple options available. You just need to worry about the pricing things, calculate it beforehand so that you don't run out of resources. Next slide. Okay, so your project might look like this. Some of your project is the front end app engine for the front end services. Then for storing your pictures, there is some picture buckets, and there in this picture many things are going on. So if I get this picture and I'm told like I have to work on this. This is a paid. How to like this is difficult to understand in first glance. So somebody need to explain those workflows to me to work on this. So there are 180 services, and this workflow can be. There are others solve this problem. Next slide. So this is Google workflow or orchestration and automation for managing your uh, coding workflows or your prod workflows, from writing your code to uh, hosting it in your multiple services. You can keep multiple services in multiple places, and this is going to give a very clear view of how your code is going to work. So if a new employee or a new developer come into this project, you want to give him this visualization, and he is going to understand what is going on just looking into this visualization. So this is also simple, and observability is very fine and secure by default. Next slide. So thank you for your time. This is it, and this is the end of our Google Camp sessions. So I'd be expecting some questions from you. Please write those questions in the chat box.